Alright, in this video we're going to introduce polar coordinates, and we're going to start by plotting polar points. So when you first learned how to plot points in the coordinate plane, you learned about the ordered pair with x and y, and you start at the origin where your x and y axes come together and meet. And if x is positive, you go to the right that many spaces. If x is negative, you go to the left that many spaces. And if x is 0, you stay at the origin. And then after you've moved for your x coordinate, if you've moved at all, then you move for your y coordinate. So if y is positive, you move up that many spaces. Negative, you move down that many spaces. And 0, you stay on the x-axis. And every point can be described by having an x coordinate and a y coordinate. Turns out, though, that's not the only way we have of describing every possible point you can put on a plane, or every possible point you can put on a piece of paper. So we have polar coordinates, which instead of going left and right and up and down, they go left or right and then they rotate. So the origin for polar coordinates they call the pole. The polar axis is like your x-axis, in particular your positive x-axis. And from there, we rotate our polar axis out a certain number of degrees or radians, and we end up at some point. So instead of going left and right and then up and down, it's go left or right and then rotate. And for this section, we'll have to keep in mind that positive angles open counterclockwise or to the left, like this one does. Negative angles open clockwise or to the right. Now for polar coordinates, we don't use x and y. Instead, we use r and theta. So first we determine how far along the polar axis we go out. So that's the value of r. And r can be negative, which means we actually start by going to the left, like we would on the x-axis with x and y coordinates. And then depending on whether the angle is positive or negative, we're going to open up our angle to the left if it's positive and open it up to the right if it's negative. Even if we start over here on the negative side, if it's positive, we're going to end up going clockwise or counterclockwise. If it's negative, we end up going clockwise. So for polar coordinates, again, we're going to start at the origin, which in polar coordinates they call it the pole. We're going to go out r units to the right if r is positive, or r units to the left if r is negative. And we're going to rotate by the amount that we're given in this angle here. And again, please bear in mind that if it's positive, it's going to rotate going toward the left or counterclockwise. If it's negative, it's going to rotate to the right or clockwise. So again, the polar coordinates for a point are given as r and then theta. So the how far out you go and then how far you rotate. Certain programs, for instance, the one that I used to create the picture in example 1, the polar grid, switch it and they use theta followed by r. But as far as math courses are concerned, it's r comma theta. So example 1, we're going to plot each of the following points. So here we have our polar coordinate plane where each of these solid circles will represent one unit. So here's 1, 2, 3, 4, etc. And we'll use each of the dashed circles for a half a unit. So a half, 1.5, 2.5, 3.5, and so forth. So we're going to start with point A, and we have the point 2 and 135. So we start at our pole, at our origin. R is a positive 2, so much like if x is a positive 2, we're going to head out 2 spaces to the right. So here we are. And now from this point, we're going to rotate 135 degrees. And each one of these spokes, these radii, for lack of a better term, spokes, is 15 degrees. So we can keep that in mind for this grid as we are plotting our points. So we start by going out 2 units to the right, and then we're going to rotate 135 degrees, and right here is where we're going to end up. So there's our first point A at 2 and 135. So again, we can use x and y coordinates, and we'll look at in a later video what the x and y coordinates for point A would be. But as far as describing this point, we could also do 2 and then 135 degrees for a rotation. Part B, we have -3 and then 3 pi over 2, or -3 and 270 degrees. One of the things also on this grid is if you notice the degrees have their radian equivalences right after them. So 3 pi over 2 is 270 degrees. So just a little helpful little piece of conversion for angles for you. So this time we're going to start at 3 units to the left. So we'll count 1, 2, 3 units to the left. And our angle is still 270 degrees and it's positive. So we are going to rotate counterclockwise or to the left. So here's 90, 180, and 270, or 3 pi over 2. So again, we start off 3 units to the left and count 90, 180, 270. I find it's easier to work with degrees in polar coordinates. So here is point B. Point C is at -1, negative pi over 4, or -1, negative 45 degrees. So we'll start out 1 unit to the left. This time we're going to rotate 45 degrees clockwise because this rotation angle is negative. So we start off 1 unit to the left, and now we're going to rotate 45 degrees clockwise, and point C should be right here. And there it is. All right, just 3 more for this example. Point D is at 3 and 315 degrees. So we count out 1, 2, 3. And now we're going to rotate 315 degrees. So 90, 180, 270, and then another 45 degrees to make 315. So right here, we should have point D. Point E is at 2 and pi, or 2 and 180 degrees. So we'll count out 1, 2 to the right, and then rotate pi radians, or 180 degrees. That's going to place us right here for point E. All right, finally, point F, -1 and pi over 3. So we'll count 1 space to the left. And now we're going to rotate pi over 3 radians, or 60 degrees counterclockwise. So again, each one of these spokes, each one of these radii represents 15 degrees. So rotating 60 degrees means we need to go count by 4. So we'll go 1, 2, 3, 4, and our point for point F should be right about here. And there it is. All right, that about does it for plotting polar points. I will see you in the next